Hello everyone. Y'all know in the previous video we had shown this FT101. This is the plane that was sent in by one of my Patreon members and donated to the channel. And what I wanted to see, will this radio work? So what I want to do is just do an evaluation of what it needs to get this radio so we can try it out. Now obviously, you know, we can see it is missing some knobs. I have most of them, and we also have the 101B parts radio that we can take parts off of. So we know we got to put some knobs on it. Now, open up the top cover, and we're going to take a look inside and see if we can see everything that's missing that needs to be replaced inside. Well, the first thing you see right off the bat, as I mentioned in the other video, is that our main relay is not present. Also, our low frequency IF board is not present. And as I said in another video, you cannot use the low frequency board out of any other Yazoo, like the B's, the E's, EE's, F's, whatever. Because if you notice here, the relay is here. It's normally here, and then there should be a noise blanker board here. But in the second generation of the 101, the noise blanker board was on the low frequency board. So that's two items that we see we got to have. I'm going to take the screws out of the cover here. See if there's anything hiding in here that looks like needs to be replaced or missing. Let me zoom you in here closer. Okay, so looking in the radio, we can see that our antenna changeover relay is also missing. So we know we got to get one of those and put in. Okay, I went ahead and removed the screws from the bottom cover so we can have a peek in here. Make sure there's nothing hiding that we need to address. And just looking here, I'm not seeing anything that's standing out. Let's remove this cover plate and see what's hiding in here. Alright, taking out the last screw. And we can get in here and take a good look. Well, the good thing, I am not seeing anything fried. Screen resistors look good. The resistor over here looks good. We can see our 1500 ohm resistor here looks okay. Now under this board is a couple of resistors and that notorious domino style capacitor that goes out and shorts and causes the final twos to red plate. and both of those resistors look good. And if we look down in here, we can always see somebody has changed this over to a 82 picofarad silver dip cap, which is what I normally do in the radio. Now I normally put some dressing on the leads there. As you can see, these are just running free, and they got this capacitor right up against this resistor, which is not good because those resistors get real hot. So we'll have to address that in the future here. Okay, I went ahead and removed the outer case. I didn't bother filming that. That was nothing special. And we can see our crystal board is completely empty. So we're going to have to populate this and get all the correct crystals back into it. And I'm just giving it a good look over just to make sure that I don't see anything else that's going to be a surprise to us. Okay, so I went ahead and printed off this page out of the manual, and you can see our crystal layout, how it runs. This is the front of the radio. Starts off with 10A, 11 meters, 15 meters, 20 meters, 40, 80, and on this side we got 2 auxiliary, JJY, we got 10D, 10C, and 10B, and here is our frequency for each one of those crystals. Okay, I happen to have a crystal board here that was cut out of another 101 that was sent to me several years ago, and it looks like it's fully populated. So hopefully we can use these crystals to go into this rig here. So you can see our first crystal is 10A, and 10A is going to be a 34.02. And I'm going to pull this crystal, and we're going to have a good look at it. In fact, better than that, I'm going to put it under the microscope because it's a little hard for me to see. So this is a 34.020. Our next one, which is going to be X5, it's 11 meter crystal, and that should be 33.020. We got 33.520. Alright, so what I'm going to do, I'm going to go ahead and go through here and look at the rest of the crystals, because the writing on them is very difficult to see. And this came out of a newer radio, so it might have some different crystals in it. Like this one's 33.520. And our crystal list, we don't have a 33.520. We got a 33.020. So this looks like this may be the upper portion of the 11 meter band. So we'll leave it out for right now. The 15 meter crystal being X4, it's going to be 27.020. And this is 27.020. Yep, 27.020. We got X3, which is 20 meters. 20 meters is going to be 20.02. And that's 20.02. Now X2 is 40 meters, and 40 meters will be 13.020. And we have a 13.020. So that'll go in slot 2. And then slot 1, which is 80 meters, and 80 meters should be 9.52. And the last crystal in this side is 9.52. Alright, starting with 10B, going to be X7. We're looking for a 34.52. Okay, we got 34.52. That's going to go in X7 slot. Our next one's going to be 10C on X8, and X8 should be 35020. And we got 35020. And then 10D, which is in X9, and X9 is 35520. And that's say 35520. Yes, that's 35520. And then we got JJY, which is X10, and X10 is 16.02. So let me see if we have a 16.02 here. Yes, we do. So the last two slots here are auxiliary. Now, we do have two crystals left. We got a 7.520, which is not on that list, and a 33.520, which is not on that list. And it looks to me like they had used this 33.520 for the higher end of the CB band. So the only crystal that we like for having this completely filled out will be the 33020. I haven't looked yet, but we probably can get one out of the spare parts 101B radio to put in this, and that will finish that out. I can't figure out what this 7.520 is, because at 60 meters that would be 5 megahertz. Okay, I looked in the spare parts rig and did not have that crystal in it, 3302. So just for time being, I'm going to stick this 33520 in there and let it go with that. I'm not really worried about that frequency anyway, but you know, I do like to have things complete. Okay, that takes care of the crystal complement. Now, as far as the two relays, I do have relays that'll fit this socket. However, to make them work, I will either have to rewire those sockets or go on the relay, take the relay apart and change the wiring on the relay, which would probably be the best way if I was to do that, and that would solve the relay problem. But those are brand new relays, and I would rather keep them from something else. So we have the relays out of the parts rig that we will put in here. Okay, I got both relays, so we'll go ahead and get them installed. Now, as far as the big relay, it'll only fit in there one way, so no problems with that. And that went right in there. The small relay, if you look at the contact side, that faces the tube this way, because you can actually plug that relay in backwards. So always put the contact, the movable contact, towards your final tubes. And there we go. So we can see both relays are installed. And it was surprising to me, the parts radio actually had the wire clips that holds these relays in place. So the only thing missing is our low frequency IF board, and we have to have that before we can go any further, because without this board nothing's going to work. So on the back of the FT101 you have an accessory port, and you're supposed to have a optical plug that plugs into that has pins 1 and 2 shorted together. I am out of these. I do not have no more. They're not cheap. I think they're going about 20 bucks or so now. So all I got is 2 tube pins from an old tube with a jumper soldered on them and plugged straight into the socket. And that's just for testing purposes until I get a regular socket. But we're missing the fuse lamp and cover. So as you can see, our spare parts 101 does have the jumper plug in it, and it also has the fuse lamp and the fuse lamp cover. So we're going to borrow this from that radio and put on this one. And the little glass cover just screws right off. Then you got a bayonet style lamp that goes back in it. And looking at this one looks okay. But let's check it to be sure. Yep, that one is good. So what this does is it's just ahead of the antenna port. So if static electricity was to come down the coax, or even a mild lightning strike, it will go through this lamp and hopefully blow before it gets to the main circuit. So again, we're missing some knobs off of this. The AF knob, the select knob up here, our plate control knob, and our band switch knob, and the VFO knob. So all I'm going to do is just take them off of this radio and put them on here. Now I have most of these knobs, but I do not have an extra VFO knob, and I do not have the small shaft for the AF gain. Now I know I'm taking stuff off of this radio, and you know that was the idea of it, but I'm not going to cut nothing out. I'm going to leave it so that if this radio ever needs to be put back together, all you have to do is put stuff in it. Alright, we got all the control knobs on, all but the band switch. And why don't we go ahead and put that on where we're not sure where this band switch is sitting at. Because as you know, in the FT101, the band switch will go 360 degrees. So I'm going to set it on 10A at the moment, which is straight up. And we'll go in here and look where our wafers are sitting at, and we'll duplicate it on the other radio. Okay, so what I did, I rotated the switch until I can see this one only has one tang in it that connects to it. I turn all the way around to it's just at the top right here, and that puts the band switch on 10C. So I just got to duplicate this on this radio, and the band switch will be right. Okay guys, we got our jumper plug in. We got our fuse lamp that was missing in. We have both of our relays in. We have all the crystals in that was missing. And now we have all the knobs on the radio. And there's only one other thing we was missing on on this particular radio, and that would be this low frequency board. Now, as I mentioned before, you cannot take a low frequency board out of a B, E, EE, EF, EX. Those will not work in this radio. You see, this is the PB1183C, and the reason, now it will plug in. You can plug it in there, but it's not going to work. And the reason for that, because the noise blanker is built onto the board that goes in this radio. Well, I went on eBay, and there was a seller I bought stuff from before, and he happened to have the correct board that we need for the Plain Jane 101. And to be honest with you, this was the only one I could find. There was no other ones up there, and searching around, I found no other ones. Now, as you can see, this one has a whole lot more circuitry on it compared to, on the left hand side, compared to the standard board. Now, a lot of it's the same, but it has the noise blanker circuit put into it. And this is the 1080A, PB1080A. And this board looks pretty good. And I think I gave $89 for this plus tax. And you can buy this board between $40 and $55. Now, why is this board higher? Well, these boards are a little bit more rare than the other boards. Plus, we have a CW filter on this board. So, you know, you have to pay for that too. So we'll take this. Oh, look, then the pins look clean. You got a capacitor here. You have got to move to get this thing in here. And all you do is set it so that it'll go down in between the metal shield and the meter. And now that board's installed. So all I got to do is get 2 screws and put in it. Okay guys, so everything's done. The radio is together. We don't have any covers on it. The PA compartment is completely open. So when you're working on something like this, you know, be careful. And if you're doing it at your own risk. Now, I don't suggest anyone to do this next step that I'm going to do. I've got the unit plugged into the mains, and I've got the RF generator connected to it, and I've already got the generator sitting on 14.200 AM, 30% modulation, and minus 20 dBm. I want to see if we're going to hear a signal. And instead of going through a variac, set the volume down, and we're just going to hit the power button. And right off the bat, I can hear the fan in the back making all kinds of noise. So it sounds like the bearings may be gone in it. And we can do away with that by just unplugging it. But we don't need the fan at the moment. I do have another one that we can put in there. Okay, radio's in AM mode. RF gain's up, volume's down. We're in internal. We're going to change this over to 20 meters and see if we have that put in the right position. Clarifier off. We'll set the plate at about 20 and the pre-select is about 20. Mic gain, carrier doesn't matter. Turn the volume up. And we have static. That's a good thing. Okay, I'm going to turn the RF on. The RF is on, and let's dial it up. It's hearing it. Pre-select's peeking out. So we are receiving a signal. However, I do not see the S meter moving at all. The S meter is not doing anything. Alright, so here's a way to check the S meter to see if the S meter is working. Take your RF gain, turn it backwards. Nothing happened. Usually when you turn the RF gain down, you'll see the meter climb. This one did not do anything. So it looks like we may have a bad meter in this radio or some circuitry in it. Now also remember, the meter is adjusted by this IF board we just put in. Well, I've connected our test meters up to the other meter, and we'll rotate the RF gain back, and you can see nothing has happened to either one of them. So it looks like the meter may be okay, but the circuit that drives it is not working. I've already adjusted the little part on the top to see if that will make a difference. Nope, nothing is working, so something in the meter circuit is bad. Well, unfortunately, we cannot check out the transmitter because the meter is not working, and you can't set the bias, and you don't want to go keying up if the bias is not right, because if the tubes are any good, they won't be any good if you don't have the bias set right. So we'll check the calibrator. You can see the calibrator works on 25. Let's go to 100. It's working there too. I got it hooked up to an antenna, and the receiver is way down. I'm on 10 meters, and I can hear somebody in the background talking. But they're very low, and I don't know how the band conditions are today. I'm going to try 20. Pre-select. So guys, we're going to say this is a partial working radio. It does receive, the receiver's way down, but take this in mind. A lot of stuff been pulled out of this radio and replaced back. The biggest thing being the crystals. So those crystals I put in there are not the same ones that came out. So they're going to be off from their original settings. So all those crystals have got to be tuned back in. So, there's another complete alignment that's got to be done on this. And then do some troubleshooting, find out, what's going on with the receiver, why is it down. And I'm not sure. There could be a break in the antenna line. It's hard to tell. The RF path coming in, just because I put a fuse lamp on there, don't mean that's going to work. That socket could be dirty. It could be all kinds of things. We're just going to have to, when I get the time and get this restored, we'll get all that straightened out then at that time. Well, I went ahead and swapped in another PB1181. That's the RF board. I know that was good. That's in there. Put it in there, fired it up, no change on the receiver's still down. Okay, with the receiver being down and the S meter not doing anything, that could be related to each other. We'll have to troubleshoot that and find out to see what could be multiple problems. You know, there could be several different reasons why the receiver's down, and a couple of reasons why the S meter's not working. So guys, I've been sitting here going through this, trying to figure out why the S meter's not working and why is the receiver so low. Now, you know, we add a lot of components, and I installed this low frequency board, and something caught my eye a moment ago. Let me see if you can see it too. Put a little couple of biscuits under here, and let me get the camera so you can see better. Okay, so looking there at the board that we installed, and look at this metal plate, and looking at the screws to hold the filter on is right up against this metal plate. So I'm wondering now, you know, because the S meter is on this board, the circuitry for it, and it makes you wonder if something is shorting out, because this plate is turned around backwards. It's supposed to be turned the other way around, so it's about center of both of these boards, and you can see it's right up against this board. So I'm going to take all this loose and swap that around. Not sure if that's it, you know. I mean, we don't know the issue with this radio. We don't know if something catastrophic happened to it and kept it from working, or what the deal is, or somebody just started taking it apart. So let me go ahead and pour this out and swap it around. Okay, I'll just go ahead and remove the two screws I put in here. We'll set these off to the side. Remove the IF board. And there's two screws on this side need to come out. Now I'll take the two screws that's holding this little metal shield on out. And we'll just turn this right around. I probably should have caught that when I put the low frequency board in, but it didn't dawn on me at the time. Like I said, I'm not saying that that's what the problem is. Now all I got to do is turn these around, because see the long sticking out this, and this is short. So we turn these little brackets around. And we'll leave them loose at the moment. Do the same to this one. can plug our AF board back in. It's kind of funny that the screws that hold the metal plate in and the screws that bolt these brackets to the metal plate are magnetic, and the rest of the screws are not. You kind of got to hang on to them so you don't drop them in there, and then you got to go fishing. Alright, now we can tighten all these screws up. Alright, all those are tight. Mark washer fell off. I had to go back and find out which screw it came off of. Now, let's just see if anything changes. Okay, I lowered the camera down. We'll plug the mains back in. Turn the radio on. Turn the generator back on. Look at that. S meter is working. And the volume sure sounds a lot louder than it did. Alright, let's try. Turn the generator back on. Alright, let's turn the generator back on. Turn the volume down. RF gain wide open. That's putting 50 microvolts into it. Amplitude. Let's go 80 dBm. That's minus 93 dBm. We can still hear the tone. And you see we're putting minus 93 dBm into it. 30% modulation. That receiver is a lot better than it was. Alright, we'll turn the generator off. Okay, the receiver's coming up pretty good when you're running it through the generator, but on the antenna, I'm not really getting a whole lot. It almost like we have a VFO issue. See how loud the signal was to start with. Now I can't pull it in.
That's not me, that's the other guy that had this call.
All right, thanks, Sherman. Have a great day down there. Later. Sure, this is W1 Alpha Alpha, Whiskey 1 Alpha Alpha IMD station. Alpha Alpha 8, Lima.
JL. 59 plus
Here in Marion, Massachusetts. The operator name is Henry, and could you just state and your name?
Yes, thank you for making my call, Henry. My name is Tim, and I'm
Yeah, very good. I copied that. Michigan, and that's a huge state. And I think if you look it up, I think that state has as long a shoreline as any state in the country.
So this you can hear the receiver coming up and drop it back down.
We're in Marion, Massachusetts here at the old Marconi site, right next to the transmitter building, which is huge. It's right.
Okay, so we know we got an issue in the receiver somewhere, and I'm leaning towards this VFO is probably going to have to be removed and cleaned, get all the old grease out of it, so that the VFO rotor is making a good connection for ground. But we can see now our S meter is working. So since we have an S meter working and the receiver is working some, I just want to give the transmitter a quick little test. We've already got it tuned, pre-selected for maximum noise. We got the tune mode, or the band switch in tune mode. We have the mode switch in the tune mode, and what we're going to do is flip the Marks PTT box switch up to Marks and see if we have any idle current. And I'm going to put a screwdriver into the bias adjustment part, and I'm going to flip this up, see if there's anything. See nothing. And tuning that back and forth changes nothing. One thing that I do see when I did that was I've got the spectrum analyzer on, and we can see a blip come up, so we know that the transmit oscillator is working. And if we look at the Rigol, we can see it also. So I'm going to hit Marks, tune the pre-select for max, go to plate, that's at max, and loading is maxed out. But there is no meter deflection, and there's no output power on the watt meter. So that tells us that either the tubes are bad, or there's some bad components in the RF stage, and that big 5.1K resistor could also be bad. So with the power off, everything disconnected, the AC mains are disconnected. We'll loosen this screw on this trimmer board, and we'll remove this bottom screw completely. Set that aside, then we can pull this trimmer board out and down, and we can look in there. If you remember, C13 of these things go bad quite a bit, and looking in there I can see someone has replaced that with a silver dip. So that might be okay. But also looking at that big 5.1K resistor, we can see just how white looking it is. And looking right here, it looks like a little hole in it. So that's possible that resistor is bad. Well, it looks like we're showing about 12K, 13K. It's possible that resistor's open. I kept calling the 5.1K, it's actually an 18K. But anyway, looking at that, it's sitting at about 20K. So that doesn't seem to be the problem. I'll get in here and check the 5.1K. And that's checking about 4.5K, so that's not the problem. Okay, those resistors both check within tolerance, but however they will need to be replaced. It's always a good idea to replace that. Like I say, C13 has already been replaced with a 82 picofarad silver dip. So this inductor was bent over, so I couldn't see that resistor. But if we look at this resistor on pin 3, we can see right there that that resistor is burnt and cracked up. There should be a 100 ohm resistor in our screen circuit. I replaced that 100 ohm resistor, and as soon as I put power on, that resistor went up in flames. So what does that tell you? You can pretty much believe that we have some shorted tubes. So as you can see, without even doing a short test, we can always see that this tube is shorted internally. It should short on 5 and 9, or 5 and 0. And we know that tube is no good. And the second tube, we see the exact same thing, and if we do a emission test, it goes to 0. Okay, this is one of the original Japanese 6JS6 tube. We see there's no short light, and when we go to test, we're showing an emission of about 80. So we know that one's good. Okay guys, tubes have been replaced. We have another new resistor put in, and it's time to see if anything's going to happen. Turn the carrier halfway. We're just going to key the mic and see if put in IC position, and we saw that meter go up, and the bias is very high. And we want the bias at about 60 mils. That's going to be about 3 marks on this bottom scale. You see 0 to 0.1. 0.1 is 100 mil, so we want it at about 3 marks. And there's our bias setting. Now we had peaked out everything looking at the spectrum analyzer earlier, but now we should have something that will produce some power. So we'll go over here to marks and see if we have anything on the meter. And we do not. I'm going to rotate the carrier, and yes, we can see power coming up. Put the marks. Oh yeah, there we go. And if you're doing this with a watt meter, just pretty much peak everything out. There we go, that's 100 watts output. We'll go to upper side band. I got the microphone plugged in. Test 1, 2. We have no audio because the audio is cut completely down. We'll turn the audio up. Check 1, 2. Audio. Check 1, 2. Test audio. Audio. And we have output power. So guys, we've made quite a bit of progress with this. Transmitter seems to be fully working. Audio system's working and transmit. The only thing we don't have is a receiver that's good and hot. One thing, you don't even need a service monitor for these radios. You can always use the internal calibrator. It's connected right to the antenna port, and we can turn it on, and if it's right, it should give us about an S9. And you can see it's below, it's about an S1. And even let's see, if we try to turn the adjustment screw with a meter, does not go no higher than that. So we know the receiver is down. Now keep in mind, we changed crystals. We did a lot of adding in to missing things. Those relays, I do not know what kind of shape they're in. They were taken out of the spare parts 101B that we had, and those relays could be dirty and not letting the signal pass through. So when we go to restore this radio, we need to check those relays and do a complete full alignment on this radio. And it looks like we're going to have a good old original FT101. So guys, we'll go ahead and cut the video here. I think we did enough. We found out that this radio does have potential. It should work. It looks like everything's working. I'll put the receivers down. And I was kind of hoping that those tubes would have been good, because my supply of 6JS6s is running real low, and I need to find some more. Now, like I say, you can convert these to 6146s. I don't suggest it. I only know one guy that had a good success story of doing that, and he was a local. But this guy was really smart and knew how to go through this thing. Several people that's done the 6146 online, they've always found some kind of other problem. There's pros and cons for doing that. So, you know, I'd rather not go that route, putting 6146s in these radios. But again, those 6JS6s are getting hard to find. Anyway guys, I'd love to hear your comments down below. If you like the video, please give me a thumbs up, and we'll catch you in whatever we're doing next. See you now. Bye.